practical idea. In this section, we'll see how to assign truth values to propositions bigger than the ones before. So we'll leave the applications of connectives for a future video. Let's do some exercises. Suppose we want to know the truth value of the next proposition. P implies that Q implies P and Q. We can compute it depending on the values of the letters that form it, P and Q. In order to do so, just like we did before, we need to construct a truth table. But where do we start? We only had 3 symbols before, sometimes just 1. Here there are a lot. Well, we'll use the principle of extensionality, which says that the truth value of a proposition depends on the truth value of its subpropositions. In other words, our proposition is formed by P, and Q implies P and Q. And the truth value of these two will give us the truth value of the principal one. But if we pay attention, we need to split the second subproposition 2 in Q and P and Q, and so on until we only have simple propositional letters. Another tip to deal with these things: just like in the algebra of numbers you learned in school, whatever is inside parentheses you should always compute first. Thus, the first thing to analyze here is the conjunction P and Q. We already know the value of this because we analyzed it in our previous lesson. Remember that it is only true when both P and Q are true. Next step is to analyze the implication Q implies P and Q. Remember that this implication will be false only when Q is true and P and Q is false. Finally, we'll study the whole implication. So in this case, 1 implies 1 has value 1. 1 implies 1 has value 1. 0 implies 0 has value 1. And 0 implies 1 has value 1. Weird. It doesn't matter what value P or Q take, the proposition is always true. We'll analyze this kind of propositions in a future video. But first, to get experience during these exercises, we'll try another example. Let's try with P and Q implies P or Q or R. It doesn't matter that it has 3 propositional letters. The principle of extensionality is still useful. So let's split the formula and see what its truth values are depending on P, Q, and R. We'll have more cases because there are more letters. In total, we'll have 8. 111, 101, 100, 110, 011, 001, 010, 000. Then we analyze P or Q. Remember that this one will almost always be true, except for when P and Q are both false. Now let's see a bigger disjunction. And like in the previous case, the only time when P or Q or R will be false is when the 3 letters are false. Next step is the implication Q implies P or Q or R. This will always be true because when Q is 1, the disjunction is 1. Finally, the conjunction P and Q implies P or Q or R will only be true when both propositions are true, and it will be false when one of them is false, and in this case it will be false when P is false. To master this kind of exercises, I suggest you to practice making truth tables of the following propositions, and if you feel like it, put some in the comments. P implies Q implies R, P or Q and R, P and Q implies P or Q or R, and P and Q implies P and Q. Thank you very much for watching. If you like the videos, like, subscribe, comment, or share. See you next time.